In this explainer, we're diving into a fascinating mystery, one that literally bridges the gap between old-school pen and paper and the absolute bleeding edge of theoretical physics. What we're about to explore is a deeply visionary concept. It's a theoretical blueprint for something called an interstellar quantum telegraph. We're going to unpack these wild ideas, figure out exactly how they were supposed to work, and then we're going to put them to the ultimate test against the unbreakable laws of our universe. Let's get started.
Right off the bat, there's just something incredibly captivating about the tactile, almost frantic nature of these handwritten notes. What we're looking at here is the raw, unfiltered thought process of a truly brilliant mind grappling with one of the most agonizing realities of deep space travel. I'm talking about the crippling time delays of communication. Just imagine being on a ship where a simple hello to mission control takes years to arrive and years more just to get a reply back. These notes represent a passionate, desperate attempt to shatter that barrier and solve the profound isolation of the cosmos.
Section 1. The Information Problem.
Okay, let's dive into this. As humanity dreams of expanding outwards, say making the jump to Alpha Centauri, we face a fundamental disconnect. The further we move away from Earth, the more isolated we become, essentially trapped in a bubble of silence dictated by the vast, empty distances of space. Now, to solve this, the author's notes feature a prominent, almost shouted word, celeritas. It's the Latin word for speed, and it's actually the origin of the letter c in physics, which represents the speed of light, roughly 300,000 kilometers per second. But here's the kicker. The author isn't just trying to match that speed. Their ambitious goal is to bypass it entirely. They want to transmit data instantly to keep deep space astronauts perfectly seamlessly synced with Earth. Basically, they want to beat celeritas.
Section 2. The Hypothesis of Resolution.
So, to solve a massive macroscopic problem like interstellar isolation, this visionary turns to the microscopic, strange, and honestly, endlessly fascinating world of quantum mechanics. How would this quantum telegraph actually work in practice? Well, the theoretical steps they lay out are just brilliant in their simplicity. Step 1. You take pairs of particles, like electrons, and you highly correlate them right here on Earth, placing them into a state of quantum entanglement. Step 2. You load half of these entangled particles onto your spaceship, and you keep the other half securely on Earth. Step 3. By measuring the quantum components, specifically the spin, of the particles on Earth, the state of the paired particles on the ship manifest instantly across light years. In theory, this allows for the instantaneous sending and receiving of information. Boom, instant cosmic internet.
But why is this instant transmission so absolutely vital? Well, it all comes down to time dilation. If a crew travels at relativistic speeds to Alpha Centauri, they might experience a mission lasting only 8 subjective years. But back home on Earth, many more years will have passed. Without this quantum telegraph providing a constant, dense, and rapid flow of scientific data from Earth, the crew would return home horribly out of date. They need this continuous sync to make their compressed, precious research time actually valuable.
Section 3. Engineering the Quantum Device.
Now, what's really interesting about this slide is the sheer scale of what we're talking about. A theory is just a theory until we actually build it, right? So how could we physically construct a machine capable of sustaining this continuous instant communication for an 8-year journey? Take a look at this number, 53.7 billion. That is the staggering approximate number of hydrogen atoms in just a single cubic centimeter of gas at standard room conditions. The author's notes suggest using multiple pairs of electrons, and when we look at the physics, a tiny pocket-sized device could hold a massive reservoir of these quantum pairs. It's like having an almost limitless ammunition depot for firing off quantum data.
However, there is a pretty massive engineering hurdle here. If we used hydrogen gas like originally thought, the atoms would bounce around and collide constantly. This would destroy that fragile quantum entanglement almost immediately, a process physicists call decoherence. So, to make the author's vision an actual reality, modern physics tells us we'd need to upgrade to scientifically superior solid-state materials. Think of things like nitrogen vacancy diamonds or rare earth crystals. These solid matrices literally lock the atoms in place, protecting the electrons from outside noise and preserving those precious quantum states not just for milliseconds, but for years.
Let's move to and see how this builds into an actual communication system. To make this work, the notes specifically hypothesize using at least 3 pairs of electrons at a time rather than just one to receive and send complex information. By utilizing billions of pairs locked inside a solid-state drive, we could create position-based character sets. What does that mean? Well, instead of just reading a random spin, the exact physical position of the changed particle inside the device could act as a specific letter in an alphabet. This massive built-in redundancy is exactly what would guarantee the author's vision of a continuous, rapid, and dense flow of data.
Section 4.
the limit of physics.
Up to this point, it is a beautiful, elegant, and highly logical blueprint. But you know, every great narrative has a plot twist. And here is where this visionary blueprint collides head-on with the cold, harsh, and unbreakable laws of our physical universe. So the crucial point is the no communication theorem. This operates as the ultimate cosmic speed limit. It's a fundamental law of quantum mechanics, explicitly stating that quantum entanglement cannot, under any circumstances whatsoever, be used to transmit usable information faster than the speed of light. This right here is the physical law that shatters the dream of the instant quantum telegraphy.
Let's dismantle the theoretical mechanism for a second to really understand why this happens. When Mission Control on Earth measures their particle, the entangled particle on the spaceship does indeed react instantly. That part is true. But the result of that measurement, it's completely random. You cannot force an electron to be spin up to send a 1 or spin down to send a 0. You literally have zero control over it. For the astronauts to know if the random spin they're seeing is a deliberate message or just quantum background noise, Earth has to send a traditional radio signal to verify it. And that radio signal, you guessed it, it travels at the painfully slow speed of light.
Furthermore, there's a huge logistical nightmare hiding in the background. Every single time you measure a pair to send a bit of data, that entanglement is permanently broken. It's gone. Once the spaceship's onboard supply of entangled pairs runs out, and it doesn't matter how many billions you started with, you can't just beam more up, you have to physically create new pairs back on Earth and physically transport them to the ship on a resupply rocket. A rocket that, of course, travels at sublight speeds. We're right back where we started.
Section 5. The Paradox of Relativity.
This brings us to the ultimate paradoxes created when human ambition tries to cheat the foundational fabric of time and space. Why is the universe so strict about this speed limit anyway? Because in the realm of relativity, transmitting data instantly across relativistic speeds doesn't just mean getting an email faster. It fundamentally violates causality. Because of the weird way time bends at high speeds, a faster-than-light message could, theoretically, arrive in the past. It could literally be received before it was ever sent, completely breaking the logic of cause and effect that holds our entire universe together.
And this brilliantly illustrates a subtle logical flaw in the original notes regarding time. You see, the author hoped that a dense, rapid delivery of data would make the time needed for the astronauts' research much less. But receiving data faster doesn't magically speed up human biology. Even with instant information beamed directly into their computers, the astronauts still have to physically sit there, read it, process it, and run experiments. 8 years of subjective time is still 8 biological years of aging, working, and living, no matter how fast your internet connection is.
But, we really shouldn't look at these notes as a failure. Actually, quite the opposite. They are a profound, beautiful exploration of the universe's limits, entirely driven by the deeply human need to stay connected to one another no matter how incredibly far we travel. The quantum telegraph might be impossible under our current understanding of physics, for sure, but it leaves us with a thrilling question to ponder. As we reach further and further into the stars, will our desperate desire to connect across the cosmos ever find a way to finally outpace the unbreakable speed of light?